Hello friends. In right triangle ABC, the angle at vertex A is 60 degrees. Point O is the midpoint of the hypotenuse AB, and P is the center of the inscribed circle. Find angle POC. As usual, pause the video now and try to solve the problem yourself. Since triangle ABC is right-angled, the midpoint of the hypotenuse is also the center of the circumscribed circle. That means point O is the center of this circle. Therefore, segments AO, OB, and OC are radiuses of the same circle, and consequently, they are equal. Now let's consider triangle AOC. We can see that it is isosceles because AO equals OC. In an isosceles triangle, the base angles are equal, so angle OCA is also 60 degrees. Moreover, the third angle must also be 60 degrees, since the sum of the angles in a triangle is 180 degrees. If all three angles are equal, the triangle is not just isosceles, but equilateral. Therefore, AC equals AO, and also equals OC. We'll use this later. Now let's look at segment PC. What if I tell you that this is the angle bisector of angle BCA? Indeed, let's recall a property of a triangle with an inscribed circle. If we take any triangle and inscribe a circle in it, the center of that circle lies at the intersection of the angle bisectors. You can see this directly. No matter how I stretch the vertices of the triangle, the center of the inscribed circle always remains at the intersection of the bisectors. The angles on both sides of a bisector are always equal. This is easy to explain. A bisector is always at equal distances from the sides of its angle, and the center of the inscribed circle is, by definition, at equal distances from the sides of the triangle. Therefore, the incenter always lies at the intersection of the angle bisectors. Since PC is the bisector of the right angle BCA, it divides that 90-degree angle into two equal parts of 45 degrees. Therefore, angle PCA equals 45 degrees. We already know that triangle AOC is equilateral, so all its angles are 60 degrees. Hence, angle PCO equals 60 degrees minus 45 degrees, which gives us 15 degrees. Now let's consider triangle PCO. We already know that one of its angles is 15 degrees. If we prove that segments OP and PC are equal, then the base angles of this triangle will be equal as well. To do this, let's draw segment ML through point P parallel to AC. Note that PL equals the radius of the inscribed circle. Let's denote it by KR. Now drop a perpendicular from point M to base AC. Notice that angle OML is also 60 degrees, since AC and ML are parallel and AB is a transversal. Next, draw another perpendicular from point P to segment AB. Let's denote that segment NP. It is also equal to the in radius ER. Now that all constructions are complete, let's compute. We will express segments AC and AO in terms of the in radius R. Segment AC equals PL plus MP plus AK. We already know that PL equals R. The ratio NP to MP equals sine 60 degrees. So MP equals NP divided by sine 60 degrees. Since NP equals R, MP equals R divided by sine 60 degrees. Because sine 60 degrees equals square root of 3 over 2, we get MP equals 2R divided by square root of 3. Segments AK and MK are legs of right triangle AMK. The ratio AK to MK equals cotangent 60 degrees. Since MK equals R, we get AK divided by R equals cotangent 60 degrees. And cotangent 60 degrees equals 1 over square root of 3. Therefore, AK equals R divided by square root of 3. So AC equals r plus 2, r over square root of 3 plus r over square root of 3. Now let's find AO. It equals AM plus MN plus NO. The ratio MK to AM equals sine 60 degrees. So AM equals MK divided by sine 60 degrees, which again gives 2r over the square root of 3. Segments MN and NP are legs of right triangle MNP. The ratio NP to MN equals tangent 60 degrees. Since tangent 60 degrees equals the square root of 3 and NP equals r, we get MN equals r divided by the square root of 3. Thus, AO equals the sum of these expressions. Earlier, we proved that triangle AOC is equilateral, so AC equals AO. Since we have expressed both in terms of r, we obtain an identity. Simplifying it, we find that NO equals r. Now consider two right triangles, ONP and PLC. Their corresponding legs are equal, and each equals r. Therefore, their hypotenuses are equal as well. By the Pythagorean theorem, PC equals the square root of LC squared plus PL squared, which equals r square root of 2. Similarly, OP equals the square root of NP squared plus NO squared, which also equals r square root of 2. We have just proven that PC equals OP. Therefore, triangle PCO is isosceles, and angle POC equals angle PCO, which is 15 degrees. Answer, 15 degrees. If you enjoyed the video, please like and subscribe. See you soon.